What if I told you that this Swiss airplane is flying on fuel made from literally nothing but air and sunlight? Not biofuel, not hydrogen. Actual jet fuel, chemically identical to what powers every commercial flight, but created by pulling CO2 directly from the atmosphere. This isn't science fiction. This happened in 2025, and it's just the beginning of a revolution that could change aviation forever. Aviation accounts for about 3% of global CO2 emissions, but here's the problem. You can't exactly put a battery in a Boeing 777 for a 15-hour flight to Singapore. The energy density just isn't there yet. So while cars are going electric and ships might run on hydrogen, aviation needs liquid fuel. The question is, can we make that fuel without drilling it out of the ground? The answer is increasingly yes, and it's happening faster than most people realize. Here's how you turn air into jet fuel. First, you need a direct air capture facility, essentially a massive vacuum cleaner for CO2. The largest operational one right now is Climeworks' Mammoth facility in Iceland, which can capture 36,000 tons of CO2 per year. Next, you split water into hydrogen and oxygen using renewable electricity. This green hydrogen is crucial. If you're using coal power, you're defeating the whole purpose. Then comes the chemistry magic. You combine that captured CO2 with green hydrogen through a process called Fischer-Tropsch synthesis, or newer one-step processes, to create synthetic hydrocarbons. Finally, you refine these hydrocarbons to meet ASTM D7566 standards, the same specification as conventional jet fuel. The result is drop-in compatible fuel that works in any existing airplane engine. So who's making this happen? Let's start with 12, formerly called Opus 12. They've created something called E-Jet, synthetic aviation fuel that's already ASTM certified and flying with United Airlines and the US Air Force. Then there's Infinium, building what they call Project Roadrunner in Texas, planned to be the world's largest e-fuels facility when it comes online. Synhelion took a different approach entirely. Instead of using electricity, they use concentrated solar heat to drive the chemical reactions. They just delivered the world's first solar-made jet fuel to Swiss International Airlines in 2025, and HIF Global in Chile is producing e-gasoline and e-kerosene at their Haru Oni facility, with backing from Porsche and Shell. But let's talk money, because this isn't cheap. Right now, direct air capture costs somewhere between $600 and $1,000 per ton of CO2. The companies say they can get that down to $100, $250 per ton at scale, but we're not there yet. And the energy requirements are massive. It takes about 20 to 30 kilowatt hours of electricity to produce 1 liter of synthetic jet fuel. That's enough electricity to power an average home for about a day, just for 1 liter. This means e-fuels currently cost around €3 per liter or more, compared to about 0.50 euros for conventional jet fuel. Without subsidies, airlines simply can't afford this. But here's where politics comes in to change the game. The European Union's Refuel EU aviation mandate requires airlines to use 2% sustainable aviation fuel starting in 2025, ramping up to 35% by 2050. More importantly, there's a specific sub-target for e-kerosene, at least 1.2% by 2030, jumping to 35% by 2050. This creates guaranteed demand regardless of cost. In the United States, 2 tax credits are making the economics work. The 45Q credit gives up to $180 per ton for captured CO2, and the new 45Z clean fuel credit can provide up to $1.75 per gallon for sustainable aviation fuel. These subsidies are essentially bridging the cost gap until the technology reaches commercial viability. But scaling this technology isn't easy. Climeworks' Mammoth facility has faced operational challenges in 2025, performing below its nameplate capacity and requiring workforce adjustments. The next major test comes from Occidental's Stratos facility in Texas, designed to capture 500,000 tons of CO2 per year, more than 10 times larger than Mammoth. If Stratos works as planned when it comes online at the end of 2025, It could prove that DAC can reach industrial scale. There's also the fundamental question of energy competition. Every kilowatt-hour used to make e-fuels is a kilowatt-hour that can't electrify ground transport, heat buildings, or power industry. We need massive renewable energy expansion to make this work without trade-offs. Let's be honest about the climate impact. E-fuels are only as clean as the electricity used to make them. If you're using grid power that's still partly fossil-fueled, your sustainable aviation fuel might not be that sustainable. And e-fuels only address CO2 emissions. They don't solve aviation's other climate impacts like contrails and high-altitude nitrogen oxides, which some scientists estimate could be as significant as the CO2. The real question is whether massive investment in e-fuels is the best path forward, or whether that money and renewable energy would have bigger climate impact elsewhere. Looking ahead to 2030, the industry needs to scale from today's small pilot projects to hundreds of thousands of tons of production annually to meet those EU targets. Projects like Norsk e-Fuel in Norway, planning 50 million liters per year, and multiple facilities from Infinium could make this possible. But most are still in development phases, with major technical and financial risks ahead. The companies say they can reach cost parity with conventional jet fuel by 2030-2035, but that depends on continued technology improvements, cheap renewable electricity, and sustained policy support. So, can we really power aviation with fuel made from air? The technology exists, and it's working today, but at tiny scale and high cost. The next 5 years will determine whether this becomes a niche solution for premium routes or a mainstream technology that could decarbonize flying. What do you think? Will e-fuels made from air become the future of aviation? Or are we better off focusing on other solutions like hydrogen, or even accepting that flying needs to become more expensive and less frequent? Let me know in the comments. And if you want to dive deeper into the companies and technologies making this happen, I've linked all my sources in the description below.